Thank you for tuning into my channel on the ozone technology course. This will be session 20A. It will be dealing with the fundamental parameters of a swimming pool. This session will introduce you to the knowledge of all the parameters that are used in treating swimming pool water, and we need to know this so that we will be able to make necessary changes, etc., to ensure that we get very cool, clean, and bacteria-free pool water to swim. This time we will be looking into the chemical treatment. Generally, the treatment is traditionally chlorine, and we shall be looking into the application of chlorine in the treatment of swimming pool currently. This diagram represents a small domestic heated pool. This is similar to most of the domestic pools, which consists of the pool itself, which is a tank, and it has got at least one inlet. You can have two or more, which pushes water on a high pressure from the pump, and the water is drained out through the skimmer for the recirculation. When water flows from one end of the pool to the other end, the top layer, which normally consists of all floating debris that falls onto the pool, is pushed into the skimmer box, which has a one-way flow valve. This valve will not allow water to go back to the pool. So the water that flows through the skimmer passes through a filter basket, which collects all the floating debris and all the debris of big size, and the filtered water goes through the pump, which will just pump the water into the filter, where that water is filtered. The filtered water is then taken back to the pool. In this here, in this situation, it all passes through a heat exchanger, where hot water goes in, mixes with the pool water, heats it up, and sends the hot water back into the pool. Basically, this is the basic structure and schematic flow of any swimming pool. This being the domestic pool has got the least of the number of items or equipment. This slide represents a schematic diagram of a commercial pool. If you notice that the water has got 1 megaliter of water volume, which is the normal standard pool of 25 meters. There are other commercial pools and community pools which are 50-meter longs, which will have, of course, at least double the volume of 2 megaliters. In this schematic, there is surface water that drains out through a small channel all along the top of the swimming pool, and it drains out back to the drainage basin, And the main circulation is where the water that enters into the pool, also through several inlets, will move towards the exit. It could be most likely along a big inlet which is protected from being sucked through some grates or through other exits also protected from being sucked in, particularly children's hair, clothes, etc., and cause drowning. So the pool water goes into the treatment area where you could have a flocculant added to remove any soluble organics and allowed and a filter to filter off particles, hair, etc., and then back to the sand filters. There will be two sets of sand filters that will take alternates, or they might both work at the same time. Depends on the load. The water is filtered through the sand filter and goes out to the heat exchanger, which pumps in heat, and as it goes into the pool, there will be a chlorine dosing tank which doses fresh chlorine gas, technically gas because of the commercial and not chlorine, liquid chlorine, and goes back into the swimming pool. This circulation continues, and ensure the pool is tested regularly every hour, sometimes 2 hours, to ensure there's sufficient chlorine in there and all other parameters of the pool are within the specifications laid down by the council. This slide consists of a flow diagram of the commercial pool. As I did explain to you, the water from the tank or from the balance tank goes through the strainer, is pumped into a tank which has got coagulant dosing or on-line dosing, so that any organic materials can be flocculated. At the same time, chlorine is dosed for disinfection, and filtration takes place. Once the is filtered, the filtered water goes back to the swimming pool. At the same time, the water is taken, sample of water is taken at several points, particularly after filtration, to ensure that the pH and the chlorine content is within the specifications stated by the council. The pH is also corrected to ensure the pH is between 7.2 and 7.6 or 7. The treated water goes back to the swimming pool and it's filtered back into the balance tank. The top-up water of any water loss from the swimming pool is topped up into the balance tank. The balance tank acts somewhat like a buffer. This slide gives the reason why we have to disinfect the water and do a proper water treatment. The source of infection that is in either hot tub, swimming pool water or spa water is follows: urine, sweat, dirt, lotion, sunscreen, cosmetics, soap residues, etc. Urine is particularly notable because children sometimes are unable to control themselves and tend to leak their urine. The dirt obviously comes from sources where children and otherwise tend to go into the pool surrounds. If it is grass, etc., which might bring in some dirt and rubbish. The lotions are biggest source of contamination because many of the swimming pool people using the pool in summer use sunscreen. Many of them use cosmetics, and some even have soap material with them, and these residues, etc., will contaminate the pool. So other contamination, basically, particularly if it's not an indoor pool, will be bird droppings. They are a serious source of contamination, and they can produce, they can be a source of very serious pathogens. Of course, the water will also have some bacteria and other products, and we then have to make sure that we correct and remove all the, this is what you call dissolved organics, and the dirt, soap residues, etc., are more little particles, suspended solids. They will be filtered. Then the water has to be coagulated with coagulants, pH corrected, and all and added by correction chemicals, and pH and other parameters like TDS, alkalinity, etc., has to be tested, ensure they are within the specified limits, chlorinated, and sent back to the pool. The effect of chlorination and any soluble organic material will cause trimethylamines, trihalomethanes, or organochlorides. These organochlorides or trihalomethanes are toxic and over a period of time are carcinogenic because they are part of the carcinogenic organochloride groups. So it is very important that we remove this as it builds up. This slide gives the information as to the types of contamination or microorganism hazard. One is fecally derived. You have viruses, bacteria, E. coli, Shigella, etc. Then you have protozoans, Giardia, Cryptosporidiums, and these are fecally derived. Now, this feces can be from birds, dogs, cats, animals, whatever they might be involved, and generally swimmers who are not very hygiene conscious and have their hands contaminated. The non-fecally derived bacteria are those obtained from the air, such as Legionella, Pseudomonas, Mycobacterium, and the viruses, papillovirus, adenoviruses, fungus, and protozoans. These are all possible contaminants onto the swimming pool. So, from the possible sources of bacteria, we understand the importance of treating the swimming pool water to the limit of our drinking standards. Also, we have to understand that many swimmers do accidentally or otherwise drink the swimming pool water. The government has established standards for swimming pools, which all public swimming pools must follow, and all private swimming pools are strongly recommended to adhere. For an indoor pool, we must have a chlorine of at least 1.5 ppm, a total chlorine, a free chlorine of at least 1 plus, and 10 ppm as maximum. They said ozone is 0 for ozonated treated pool, which I quite dispute. The pH must be between 7.2 to 7.8 and the alkalinity between 80 to 200. If you notice that bromine sometimes can be used as a disinfectant instead of chlorine. If that's the case, you've got to have a higher amount of bromine, 3 ppm for indoor pool, 4 ppm for heated pool, and high temperature heated pool, outdoor pools also 4 ppm, and spa between 4 and 6. Bromine is an expensive halogen. The advantage of using bromine is the fact that it has got a higher temperature stability, and therefore it is more suitable for spas and very hot heated pools. But generally it's being used only for spas. This standard must be adhered by Queensland Health, or other countries will have very similar standards. This ends this session of 20A, session 20A on swimming pool water treatment using chemicals. The next session, 20B, will continue with the parameters of swimming pool with chemical treatment. If this session is your first tune-in, please refer to sessions 1 and 2, which contain the intro and program details, and session 3 to 20 on the course to date. Please click like and subscribe. And if you wish to be notified of future uploads. Thank you and have a very good day.